Good evening, my 11th standard warriors. Today is the first lecture of Centre of Mass and we are going to complete it as a marathon session. So all of this with me, Shreyas, your physics master teacher at Vedantu. So welcome all the new students and also the existing regular subscribers. This is the Nurture series. This is a long-term series for 11th standard students. We started the Nurture series quite some time back. We completed units and dimensions, kinematics, integration, derivatives, 2D, projectile, relative, Newton's laws, friction, work power energy, circular motion. All of this has been done with Menti quizzes, advanced problem solving sessions and so many other kinds of inputs. So today we are going to start Centre of Mass, and this week we are also going to start momentum and collisions and going to try and complete it so that next week we can start and probably complete in the next coming days the chapter of rotational and system of particles. So hello Molesh, Pavitra, Dakshin, Strange 531. Strange 531, we also have advanced sessions in which we solve very difficult problems. So while we explain you the concept, we start from the basics and then we have problem solving sessions where we slowly scale up the level, and then you will also have revision series where we'll have very good problems as well. Hi Kedar, hello Narmada, hello Harita, welcome aboard. So all the lovely students out here, it's nice to see, and your especially lovely comments that you keep posting. Thank you so much. Hi Chitra, hi Tushar, welcome aboard. So it gives me Kedar is asking, I'm a JEE aspirant 2023 and is HC Verma and Cengage, is it enough? Well, HC Verma is good, but try to avoid Cengage. Instead of that, try to do Arihant, DC Pandey and Tattva. So out of these three books, choose either Tattva. If you have Tattva, you get PYQ and everything else. Else, if you are not subscribed to Vedantu, then probably you might have to switch to 2 books and then you have to spend some more time. Okay, so that's what you need to do. Thank you Saja so much, and welcome all the lovely students. Am I live from Nagpur? No, I'm right now live from Bangalore. So there is this thing which I would love to tell you, and it gives me immense joy. And by the way, before that, I can quickly introduce myself. I am Shreyas. I graduated from NIT Nagpur. I did my mechanical engineering. I went into a software company for 3 years, and after that I started teaching, and it's been more than a decade now since I've been teaching. And right now, by this time I think I have mentored more than 5,000-6,000 students easily, and hundreds of them are right now into IITs and even graduated from that, and many of my students are in the top 2-digit ranks that you can think of in the past few years. So even this year there are so many stories that you might have heard, and if you are live during our celebrations you would know this, that almost we had a 3 times growth as compared to the last year. Last year there were around 500 odd students who cleared JEE Advanced to go into IITs. This year we had a massive 3 times growth, and we had 1,500 plus students who cleared the JEE Advanced examination, and almost 60% of them were from small towns and villages where they don't have access to coaching centers or quality teachers or good material. So that's a massive jump. Imagine these 2/3 students who are from smaller villages and towns. Had they not joined Vedantu, they would never get that education and they would never qualify for from JEE Advanced. And not just this, guys. I mean, almost 1 in 10 students, okay, a little bit less than that, you are going to see the students who are going to get into IIT, almost 1 in 10 are going to be from Vedantu. So that's a massive number, and thanks to all of you, and glad that you guys are here. Hello Aishwarya, hello Vivek. Does KVPI crash course cover theory of the topic? In brief, yes Vivek. So brief theory, concept application is more important rather than the theory. So the extensive theory happens in the JEE classroom, but whatever is required for KVPI, that will happen in the KVPI classroom. Hello everyone. Welcome Meghna, welcome Ambati, hello Roshni. So if you are interested to be a part of this growth story, because you are 11th standard kids, next year the result is going to be really amazing, and you guys are going to rock it after 2 years in JEE 2023. And if you want to kickstart your journey, if you want to be with the best of the best faculty, if you want the best of the best material, then go ahead, check out the link in the description box below, because right now there is massive Dashera sale going on and you get 50% off on the 1 month pro subscription, and you also get 10% off on the long-term subscription. So these are the usual discounts that you get using my coupon code, but now when you use my coupon code, you get flat 10% off on the entire course. So these prices go down even more. So just try it out and you'll be surprised to know how much more discount you get. So let's kickstart our chapter, and that's Center of Mass. Hello Suchi Mama. Okay, so now here is the thing. See, this chapter is a bridge between two kinds of physics. Okay, two kinds of physics. Till now, every time, be it Newton's laws, kinematics, or be it circular motion, work energy, you always used to represent the body as a point mass. A bus is traveling with so and so speed going from here to here, you assumed it like a point mass. But what if the bus was turning? There is rotation and translation combined. What if I throw this pen like a projectile motion? Then you see that, the motion of each particle is very, very complicated. So when you throw this pen, you can see each particle is going in a very complex kind of a motion. So whenever you see there is translation combined with rotation or translation combined with oscillation, imagine there is a pen or some spring mass system which oscillates and travels. There are two blocks, there is a spring in between them. You compress them, leave it and push them. So they go like this. So oscillation and translation, caterpillar kind of motion. Every time such systems are to be analyzed, it's always better to look at it from the center of mass perspective, because what center of mass actually does is it splits up the motion into two different categories. I'll give an example. See, this pen, okay, which is rotating and traveling like that. Okay, so this pen was like this, then it went like this, then it went like this, then it went like this. So you can see it is turning and going. You will see that there is a point on the pen which is doing your normal parabolic motion. Okay, it is doing your parabolic motion. And if you sit on the point on that pen and you see the rest of the pen, it is doing nothing but rotational motion. It is doing rotational or circular motion. So that point is actually the center of mass, where you can assume the entire mass of the body to be concentrated. So if the pen were to be a point and thrown, that point would go in the parabolic path in the influence, under the influence of gravity. Correct, my warriors? Now if you sit on that point, what you will see is the pen is just rotating or doing a circular motion. So what has this point enabled us? This point has just enabled us to split that complex motion, because if you notice, each point is going in a very weird path. Each point is going in a very weird path. So, instead of doing that, I can analyze the motion of the center of mass separately, and then sitting on the center of mass, I can analyze the rotational motion separately. So it splits the two motions. Is that clear? Is that clear? Yep. I hope this is very, very clear now. Yep. Now, if this one is clear, let's move ahead. So Krishna, we'll talk about electricity maybe later on. You can leave a comment after the video ends and definitely I'll help you answer your doubt. Okay. And very good question, Hari Kishore. Is the center of mass and center of gravity same? No, they are not the same. Center of mass is the point where the mass is concentrated. Center of gravity is the point where the weight is concentrated. Weight is different from mass. Mass is in kg. Weight is in Newton. If you are outside the Earth's atmosphere in free space, you are floating, what is the gravity over there? Think about it. What is the gravity in free space? It is zero. It's a gravity-free environment. So what's your weight? Your weight will also be zero. So then, if your weight is zero, that means there is no gravitational pull on you, you're floating, then your center of gravity does not exist because there is no weight. There is no point where you can concentrate the weight on. So center of gravity will not be, even defined when you're floating in space. But you still have mass. That means your center of mass is present, center of gravity is not present. Is that clear? And this chapter is exclusively for center of mass. We don't have center of gravity as such in the JEE syllabus, but just for your information, these are two different things, and mass does not change when you change, gravity. Mass still remains the same. But when you go outside or when you change the planet, then gravity will change and center of gravity may change accordingly. I hope that is clear. How do we concentrate mass? So Suchi, you don't have to squeeze the pen and concentrate it. It's a hypothetical concept. If one were to squeeze an object into a point, then where would you squeeze it to? That's the location of the center of mass. You don't have to physically compress it. You are not going to think about, oh, how am I going to apply so much of force? Now, this is one of the very good example of center of mass. Look at this. This is a person holding a stick, trying to balance himself and try to walk on a rope. Obviously, what is the stick used for? The stick is somehow going to make sure, by adjusting the stick, you're going to make sure that the combined center of mass of the person and the stick lies above the thread. The combined center of mass lies above the thread. Now, why is that so? Well, let me give you a simple example. Imagine this is the rope, okay? My finger is the rope, okay? This is a rod, and imagine, okay, there is a mass attached over here. There is some kind of a mass attached over here. Now, if the mass is exactly on the top of this finger, if that mass is exactly on the top of the finger, if I somehow try to balance it, I know it's difficult now, but you might have tried to do this with a bat or tennis racket or any other long object. You can try to, keep it upright. You can try to keep it erect, okay? Trying to make sure that the center of mass is always on the above the point of suspension. If you try to keep the center of mass, or if you keep the mass above the point of suspension, it stays upright, correct? But if it loses balance, then the mass will either go here, there, or here. Then the mass is not directly above the point of suspension or the point of contact, and that's when it falls. So what you are trying to do over here is that person plus that rod, if I try to squeeze them into one single point, try to make sure that their concentration of mass, their center of mass, is just above the thread. Only then he will be able to balance himself. I hope this is clear. The center of mass is at rest during projectile motion? Definitely not, Bala. It will also move along with the object. So if I throw this pen, obviously the center of mass of the pen will translate. It will go as a projectile motion, obviously. Okay. Will center of mass always go in parabola? No, not necessary. That was just an example given to you for an object thrown under gravity. But there are many instances in which center of mass will not go in a straight line or not go in a parabolic motion. It might go in a circular motion also. Imagine I rotate this pen and make it go around. Then the center of mass of the pen will be going in a circular motion. If I make this pen go in a straight line and I translate it, then you will see the center of mass might go in a straight line. So there are different ways in which the center of mass may travel. I hope this is clear. So what is center of mass? It's the point where the entire mass of the system can be concentrated, so that you can assume as if all the other forces which were otherwise acting on it are now acting on that point. So I'll repeat. So center of mass is the point where you can assume that all the mass can be squeezed into there, so that whatever forces were acting on the entire body can now be concentrated on that point, and that point will behave exactly the same way. That's what center of mass is. Well, Google Nath has understood it. So for the same object, will the center of mass change? So Rajiv, what do you think the center of mass should depend on? In fact, I should ask this to every one of you. Let's say I have this remote. Let's say I have this pen. Let's say I have my watch. Let's say I have any other object, maybe this scissor over here. What does the center of mass depend on? Come on, quickly write it down in the chat box. I think it depends on quite a few things. Number one, Obviously, it depends on the shape of the object. So what is the shape? Whether it looks like this, or a cylinder, or a sphere, or a cone, or some other shape. Apart from the shape, it will also depend on the density variation. How is it varying? Whether it is more dense here, whether it is less dense here. For example, imagine there is some random object like this. Okay, there is a random object like this, but it's made of, let's say, an alloy, and there is more concentration of, let's say, iron here, and there is more of aluminium over here. Now we know iron is more heavier than aluminium, so the center of mass will be more towards the iron side. So this is probably where the center of mass will be. So it depends on the shape, and it also depends on the distribution of the masses. That is how the density changes at different locations. So wherever it is more dense, wherever the density, the matter is concentrated more, that's where the center of mass is going to shift. All right. One thing. Yeah. Oh, Vivek. Yeah, bacha, you can buy the KVY course from the website course section or in the link in the video description. Yes, you will get the same thing, but when you go from the link, then you get discount. So that's why go from the link which is there in the description box below, Vivek, then you'll get the best discount ever. All right. Now, the another thing which many people, get it wrong is that center of mass should always lie within the body. For example, let's say, I have this bottle out here. So the center of mass of this bottle should always lie over here. That's what many people think. That's true for this bottle. But what if I have some other object? Maybe it's not, straight line like this. Maybe what if I have some hollow object like the scissors, this part, one of this, element over here. You can see the center of mass of this plastic element will lie somewhere here where the mass does not even exist. Now this point is not even on the body. Can you see this plastic part? The center of mass, the entire mass will be concentrated somewhere over here. Now this point is not even on that body. So center of mass can lie outside the body. Another good example would be a bangle. So when you take a bangle, the center of mass will be at the center, which is not again on the bangle, it's outside the bangle. So I hope this is clear. Yes, we're going to talk about cones and other things. Yep, still this is chapter in your term 1. Yep, I hope this is clear. Yep, Anirudh, I think I just discussed the ring as well. Thank you, Madhusudan. Very good. I think everybody is getting all their doubts cleared. Excellent. And if you're loving this session, do not forget to hit the subscribe button so that you do not miss other classes. And also do not forget to smash the like button down there in case you have forgotten to do so. Now, what's the formula for locating the center of mass? We're going to slowly build up on the formula. First, let's start with 2-point objects. Then we'll bring 3 objects. Then we'll bring multiple objects. And then we'll place it randomly. And then we'll also talk about continuous objects. So all kinds of objects we'll deal with. Then we'll go to motion of center of mass, velocity, acceleration, momentum, forces on the center of mass, and those kind of problems as well. So the chapter is going to be completed today. This is a one-shot marathon session on center of mass, just exclusively for 11th standard students. But yeah, if you're a 12th standard student and want to revise it, you are free to do so. If you're taking a drop and still want to watch it, you're still free to do so. Now, here is the thing. If, for example, there are 2 masses, let's say I call this mass M1 and let's say I call this mass M2, and let's say this is the origin, okay, and this mass is located at x1 coordinate, and let's say this mass is located at x2 coordinate. x1 and x2 are the coordinates of 2 point masses. Then the center of mass will be somewhere on the line joining both of them, somewhere in between. Obviously, it can't lie here or here. Obviously, if you try to compress both of them and consider it as a point mass, it has to be somewhere in between them. Now, if M2 is more, this point will be more towards that side. If M1 is more, then it will be more towards this side. And this is your center of mass, COM, center of mass. And this coordinate will be XCM or XCOM, whatever you want to call it. This center of mass coordinate formula is given by the weighted average. You would have seen this probably in your straight lines class, or maybe you will see it soon enough, and that is nothing but M1 x1 plus M2 x2 upon M1 plus M2. This is the standard formula. Now some of you might be like, I don't believe you. It's fine. You cannot believe me. It's okay. Let me make you believe this formula. For example, the two masses are equal. Okay. So let's say M1 is equal to M2. So where would the center of mass be? It should be exactly at the center. The distance will be divided into equal halves. Let's try this out and see whether it works. So XCM will be M1 is, let's say, M2 is equal to M. So M X1 plus M X2 divided by M plus M. So it will be X1 plus X2 divided by 2, which is the average of both, which is exactly at the center. So it works every time. Well, what if I make one of the mass 0? Let's say M1 is there, M2 is 0. Obviously, the entire mass should be over here. Understand, when there are two masses, the center of mass will be in between. But when one of the mass is 0, obviously the mass should be concentrated here. Let's see whether it works. So XCM will be M1 X1 plus M2 X2, okay, upon M1 plus M2. M2 is 0. So 0, 0, nothing. M1 by M1 is 1. So you will just get it as X1. So what is X1? X1 is this coordinate itself. So the center of mass is exactly on M1. So it works every time. I hope this is clear. Yep. Thank you very much. Yes, this is like the section formula. Excellent, Anirudh. I'm just going to come to that. Now I'll teach you a trick. This formula you will get it everywhere. But let me teach you a trick which you can use for solving the problems. Okay, now this is the formula, but Shreyas Sir is going to teach you a tip. Now what is the trick? Here is the logic. Remember, the center of mass, if it is here, okay, let's say this is R1, let's say this is R2, let's say this is M1, this is M2. What is R1 and R2? Distance of the center of mass from each of the masses respectively. Keep this in mind. M1, okay, let's say for example, I shift my coordinate system over here. For example, if I shift my coordinate system right over here, this is y-axis, this is x-axis, now this becomes the origin. Think about it, the coordinate of the center of mass will now be 0, correct? The coordinate of the center of mass. I have chosen the origin to be the center of mass. So this will become M1. X1. X1 will be coordinate of M1, which is minus R1. I hope you can see that, minus R1 plus M2 into X2. X2 is nothing but this distance, which is nothing but plus R2 upon M1 plus M2. Now think about it. This is 0. So numerator has to be 0. So therefore M1 R1 with a negative sign plus M2 R2 will be 0. So take it on the other side. So M1 R1 is equal to M2 R2. Therefore M1 by M2 will be R2 by R1. What does this formula tell me? It tells me the center of mass divides the distance between the two masses, in the inverse ratio of the masses itself. You can see M1 by M2 inversely related. M1 R1, you can see one is on the top, one is below. M2 R2, one is below, one is on the top. It's inversely related to each other. Very, very useful for solving problems. Is that clear? Yes, Kedar, this is one shot. Yep. Understood? So what has happened? The center of mass divides it in the inverse ratio of the masses themselves. So very, very important result which you can remember. So how do you use it? For example, let's say this is 2m and let's say this is m. What are you going to do? I know center of mass will be closer to the heavier mass. So obviously you have to divide this whole distance. Let's say this is r into ratio of not 2:1, 1:2, inverse ratio. So divide it in the ratio of 1:2. If this is 2m, this is m, Distance wise, this will be 1, this will be 2. How will you divide r in the ratio of 1:2? How will you divide r in the ratio of 1:2? Kedar, this will be more than 2 hours, 2.5 hours maybe. Okay, so 1:2. So first of all, 1 plus 2, how much it is? 3. So divide it into 3 parts. Divide it into 3 parts. So r by 3, r by 3, r by 3. I hope this makes sense. So this will be r by 3, r by 3 and r by 3. So these two r by 3 is 2. This r by 3, 1. So 1:2. So hence this distance is r by 3 and the other distance is 2r by 3. That's how you can easily do this problem as well. Is that clear, my warriors? Is that clear, my warriors? See if this is understood. So I will take more such questions and you will probably get the sense of this formula. Let me just take one more example so that I am convinced that you too have understood this. Let's say take other example. Let's say this is 3m, this is 5m. Let's say the distance between them is r. Alright, we know center of mass will be closer towards the heavier mass. So the center of mass will be somewhere here. Okay, now this is 3m, this is 5m. So the distance will be in the ratio of 5:3. Inverse ratio, that's what this says. This is 5, this is 3. Okay, so you have to divide r in the ratio of 5:3. So first add these two. 5 plus 3 is how much? It's 8. So you will get 8 parts. Each one of them will be r by 8, r by 8, r by 8, like that. 8 parts. Take 5 parts out of r by 8. So this distance will be 5r by 8 and this distance will be 3r by 8. Isn't this simple to solve? Isn't this simple to locate the center of mass without having to actually use that formula? Very easy. I hope this is clear. Anirudh, we are just coming to that. We are going to go to more masses now. Okay, so let's start solving a question coming up on your screen now. Here it is. The distance between the centers of carbon and oxygen atom in a carbon monoxide gas is 2.8 into 10 to the power minus 10 meters. The distance of the center of mass of the molecule relative to the carbon atom is how much? Let's see how many of you can do this. Very good. Me ekdam mast hai Anup Patil. Thank you very much. All right, Suchi, this is easy. Yes, Chitra, this is easy. Okay, come on. Let's see if you can solve this question. So there is a carbon monoxide molecule and you have to locate the distance of the center of mass. Obviously, carbon will have a mass of 12 atomic mass unit. So I can just put this as 12m. M is 1 AMU. Atomic mass unit. Oxygen, all right, it will have 16. Fair enough. So this is 16m. Now obviously we know the center of mass must be closer to the oxygen. So this is where the center of mass must be. So think about it. You have to divide the distance in the inverse ratio. So if this is R1 and if this is R2, just think about it. R1 by R2 inverse ratio. So you will have 16m divided by 12m. Does that make sense to you? R1 will go with 16, R2 will go with 12. Inverse ratio always. But wait a minute, mm gets cancelled, so I have 16 by 12. But you know what I can do? I can also do one thing. I can use componendo which you have studied. I can do componendo if you have studied. So if you want, I'll just write it like this. R2 by R1 is 12 by 16. Use componendo. It will be R2 plus R1 divided by R1. Because I want R1 is equal to 12 plus 16 divided by 16. What is R2 plus R1? That is the total distance, bond length. How much it is? 2.8. So this is 2.8 into 10 to the power minus 10. 12 plus 16, that's 28. And here we have 16 and here we have R1. 28 goes and you shift that 16 over here. What are you going to get R1 as? You're going to get R1 as 1.6. 1.6 into 10 to the power minus 10 meters, which is option B. Done, done. Very good. What is componendo? Suchi, I have taught that in basic maths, one of the first few lectures of Nurture series. In case you have forgotten that, please watch it. You need to know that basic maths for sure. Without that, it will be very difficult to move ahead. So those of you who do not know what is componendo, this step, componendo, dividendo, please watch my revision classes, also the basic maths classes which I have done at the start of the nurture series. It's all there in the playlist, bacha log. Okay, please do that. It's very useful for all of you. Okay, so that's the answer, 1.6 into 10 to the power minus 10. Now what if there are more particles? What if there are more particles? It's very simple. Okay, I'll tell you what. Let's say this is M1, this is M2, like that. There are many masses. This is Mn, and this has coordinate x1, this has x2, so on and so forth, and this mass has coordinate xn. Then the center of mass coordinate xcm will be just the extension of the formula. It will be m1 x1 plus m2 x2 plus mn xn, the whole thing divided by m1 plus m2 plus mn. That's it. That's the complete extended formula, nothing else. So you just have more terms in it, so in the numerator as well as the denominator. So summation mi xi, so this is a symbol which you will see, m1 x1 plus m2 x2 plus m3 x3 plus mn xn, where mi xi, I varies from 1 to n. So this symbol stands for summation, where you keep substituting m1 x1 m2 x2 and you sum them up. And in the denominator, m1 plus m2 plus m3 plus mn, that's the total mass. So that's summation mi, where again I varies from 1 to n. So that is 1, 2, 3, 4, all the masses added together. Very simple, right? So should we use the formula of AP? No, this is not AP unless and until the masses are in AP. So you do not know what the masses are going to be. So the summation might depend whether it is in GP, whether it is in AP, or just a normal sum, or just pure substitution. Okay, so let's take up a problem based on this and see how you are able to solve this one. So there are particles of masses m, 2m, 3 and so on and so forth, and are placed on a line at a distance of L, 2L, 3L, etc. from a fixed point. The distance of the center of mass of the particle from the fixed point in centimeters is, let's see how many of you are good at maths. Let's see how many of you have attended the series and some classes in maths, maybe in your coaching, maybe on JEE Enthuse. And if you haven't, then you're going to find this part a little bit tough. So let's see how many of you can do this, my warriors. So use the summation formula for something which you have already learned. So let me just show you the diagram first. How will the diagram look like? See, it's a straight line like this. Okay, this is a line. Okay, this is the fixed point, let's say O, and there are masses kept. M, or M is over here, then 2m and 3m and so on and so forth, and you have n times of m. Okay, there are many masses in between. This is at a distance of L, this is at a distance of 2L, this is at a distance of 3L, like that. You have the nth mass which is at a distance of NL. So the question is, where is the center of mass? So I think I need to use my extended formula. So what is my extended formula? So extended formula xcm will be m1 x1 plus m2 x2 plus mn xn, the whole thing divided by m1 plus m2 plus mn. So this is the formula that I need to use. So let's use this over here and see what do we get. So xcm will be m1 is m, x1 is L, plus m2 is 2m, x2 is 2L, and so on and so forth. Okay, imagine the next term would be obviously 3m into 3L, okay, till n terms, and denominator will be m1 plus m2 plus m3, that means m plus 2m plus 3m till n terms. Now very obvious thing is that m will get cancelled both in the numerator and denominator. So you can see L is common from the numerator, L everywhere. So I'll just take L common, and what is left inside? M, L both have gone, so 1 is left. Here 2 into 2, 4 is left, and next I have 3 into 3, 9, and so on and so forth. And in the denominator you can see 1 is left, 2 is left, 3 is left, and so on and so forth. Acha, look at all these numbers. 1, 4, 9, next will be 16, next will be 25. Here you have 1, 2, 3, 4, 5, 6. So till n terms, what is it on the top? It's the sum of n square, and at the bottom it's just summation n. So if you remember the formulas, If you remember the formulas, that's it, you will get it. Hi Kalyani, good evening. Tej, the brown has gone and the black has grown by new paints, Asian paints. दीवारों पर रौनक ला दे, बालों पर भी रौनक ला दे. Okay, so there we go. So L 149. So summation of n square till n terms. What is the formula? It is n into n plus 1 into 2n plus 1 divided by 6. How many of you remember this formula? Very good. And divided by 1 plus 2 plus 3 plus till n terms. It is just n into n plus 1 divided by 2. What do you see over here? N gone, n plus 1 gone, 2 and 6 gone, 3 remaining. Okay, so what is left? L into 2n plus 1. Very good. And that's 3 over here. So is that option there? Yes, it is. 2n plus 1l and divided by 3. Done, done. Very good. Yes, Karthik. That's option A. Very good, Dakshin. Excellente. Darshan. Very good. Very good. Hi, Arjun lad. Welcome aboard. Will we have to study dynamics of circular motion before starting system of particles? Yes, RTI. You have to, because system of particles is very, very important. It is a bridge between particle dynamics and rigid body dynamics. So you will understand rigid body dynamics once you know center of mass and all of that, and you will be able to understand rigid body mechanics only if you know circular motion, because rotational motion is involved, and rotational motion will involve concepts of circular motion. So that's why you need to know it. Okay, so let's get moving to the next question coming up on your screen now. But before that, I think we have the formula for particles in 3D. So how do we locate the center of mass? So one can easily guess this now. If you have a mass m1 here, m2 here, m3 here, mn, they are all located in different points in 3D space, then everybody can tell me this formula. X coordinate of the center of mass will be m1 x1 plus m2 x2 plus mn xn divided by m1 plus m2 plus mn. Similarly, the y coordinate of the center of mass will be m1 y1 plus m2 y2 plus mn yn, the whole thing divided by m1 plus ... till mn. Similarly, the z coordinate of the center of mass will be m1 z1 plus ... So nice to write this formula. I'm pretty sure you're enjoying this because you know and you can guess this easily. mn zn divided by m1 plus ... mn. Now these are the x, y, z coordinates. If you want to write it in vector form, how do you write it? Then you write it RCM, the vector I cap, j cap, k cap will be m1 r1 bar. This bar involves something I cap, something j cap, something k cap. You have clubbed all these three together in one expression, and the last term will be mn rn, okay, bar obviously, divided by m1 plus m2 plus mn. So if you want to find the coordinates individually, you can use this. If it's in vector form, then probably you will use this formula. Is that clear? All my warriors, give a thumbs up, big thumbs up in the chat box. And also if you forgot to smash the like button, please do that right now. Okay, yeah, it's unit vectors. So Harita, very true, bacha. This is at the end of the day a section formula. It's a weighted average formula. What will be the formula for an object being particles and wave? Both. My God, Rakesh, where have you reached? So wave has no mass, so there will be no center of mass for that. Okay, chalo. So these are the formulas. I have also given it to you in the printed form. You can scare the little kids, your younger brothers and sisters, by showing this formula. But you know, this is very easy because you've just attended my class and you know what this means. Okay, so make sure that you scare all your younger brothers and sisters tonight by showing the screen. Alright, so let's move to the question coming up on your screen. And here it is. Thank you for all the thumbs up. Chitra, Kalyani, Alvinia, RVR, Dinesh, Saja, thank you. Okay. Chalo, let's do it. Chitra is going to do it today. Okay. Sir, should I want practice tests for sure to get good marks in NEET? Yes, Saja, you should practice lots and lots and lots of tests on regular basis. on bi-weekly basis and all of that, and towards the end even more, to get very good marks in NEET, else it's not possible. So center of mass of two particles, 1 kg, 2 kg, located at 202, 110, has the coordinates off. Let's see how many of you can get it. Why don't I teach chemistry? Already we have Wasim sir who teaches chemistry. So please do attend the classes of Wasim sir. He will teach you chemistry, alright? Okay, Nitish Bacha. Okay, Snehal. Okay, Dakshin says, hey, hi Dr. Alka Yadav, welcome aboard. Nice to see all of you joining in, and a lot of new students out here. Welcome my bacha log, welcome my warriors. Nice to see this family growing. Oh, and I forgot this. Today is a special day. Today is a special day. What is that special day? I'll tell you in a bit. Let me just solve this problem. I just remembered it. I mean, like, how can I forget it now? Oh my god, let's see. By the way, the center of mass of two particles is this. So let's figure this out. So let's find out x separately, y separately, etc. So x cm will be m1. m1 is 1, x1 is 2, plus m2 is 2, x2 is 1. Okay, upon m1 plus m2, 2 plus 2, 4 by 3. Okay, so that's what it is. YCM. Now, if you see x coordinate is 4 by 3, 4 by 3 is only there in this option. So I don't even have to choose and even figure out the y and the z coordinate. It has to be option A, but just for my satisfaction. Don't do this in the exam. In the exam, just find out one coordinate, and if one option matches, just mark and go ahead. Do not do what I'm doing right now. This is just in case there are 2 or more options which has 4 by 3 as the x coordinate. Yep. Okay, so let's see what is the y coordinate. So m1 is 1, y1 is 0, plus m2 is 2, y2 is 1 divided by 1 plus 2. So you can see this is 2 divided by 3. ZCM will be m1 is 1, z1 is 2, m2 is 2, z2 is 0 divided by 1 plus 2. This is also again 2 by 3. So 2 by 3, 2 by 3, yes, it perfectly matches and we are correct. Done, done. And who got this correctly? Okay. Are you? Definitely I'll teach rotation, definitely. After momentum and collisions, just stay subscribed. Yes, Suchi Mama, very true. Yes, Arita, very true. Excellente, Roshni, you got it. Finally, Rakesh. God bless you, bacha. Rakesh is only giving every Ashirwad, all the blessings from Rakesh Vemula already. He is my correspondent, he is my PA, he is my ambassador, he is my representative. Yep, it's 1 year anniversary. So we started around this time, last year. And it's a successful 1 year, what should I say? And it's something which we never thought that we would reach. We are close to now 75,000 subscribers. So we always thought that there will be very few people who would want to learn in English, because many of you might want to learn in Hindi. But I can say we not only have students who want to actually or probably only understand English, but we also have students who understand Hindi but are in English medium in their schools or colleges, and they want to make sure that there is no disturbance in the medium of understanding, and they want to continue the same trend back at school and college and in the coaching or on YouTube. So thank you for trusting us, thank you for being with us, thank you for making this family grow so big, and I'm pretty sure JEE Enthuse will continue to grow even bigger, and it will continue to serve its bigger purpose, that is give quality content, give you the right strategies and tips forever. So God bless you all, thank you all, and I really love you. Thank you for being with us and sharing all the videos and promoting by liking or whatever you might be recommending this channel to your friend, whatsoever. Thank you, it means a lot. God bless you all. All right, so let's go to the next one. Yes, Jai, I know, Jai, Kirito, there are so many students, right from the beginning I can still see them. So that means, we have been consistent, and that love has still been in your hearts. It's not gone away. You are not forgotten us. So I'm really, really happy about that. Oh yes, let's get going to the next concept, and that's center of mass of common bodies. Standard bodies. What are the standard bodies that you can think of in 3D? Sphere, cube, cylinder, all these things. So solid sphere will be obviously at the center. Obviously, right? It's uniform solid sphere, center. Hollow sphere, it's under. It's nothing inside, it's just a shell. Hollow sphere means it's empty, but only the covering, the shell is there. That is also going to be at the center. Cube, be it solid, be it hollow, it will be exactly at the center. If you draw the diagonals, alright, it will be exactly at the center. Rod, a rod which is uniform, like probably this pen, or maybe this pen, if it is made of uniform material, it will be exactly at the center. So L by 2. This is very obvious. But what about, non-uniform bodies? What if the body's density changes? What if the shape is irregular? So is there a general formula? Yes, there is. What you need to do? Take that body, divide it into point masses. But there is a catch. The catch is, when you take a body and divide it into point masses, how many point masses will you divide them into? Because it's a continuous body. So there will be many point masses. In fact, countless. So each point mass on that body will be infinitely small, and there will be countless such masses. Countless such masses. Anil, I'm going to come for cone too. Yes, I'm going to come for cone. Yeah, don't worry. So what you do is you take a small mass. What is a small mass called? And you all know it. If you have been regular to this channel, and probably if you have studied derivatives and integration back in the day. So dm is the teeny mini mass. How many dm's will be there? Countless. dm. There will be so many dm's. Each one will have a different position vector, because each dm will be different places, different lengths, different densities. So there will be many dm's. Now usual formula. So what is the formula for the center of mass? Here it is. So the center of mass is located by this formula. Look at this. So usually the RCM will be M1 R1 plus M2 R2, like that. There will be so many terms divided by M1. Okay, M1 plus M2. So many terms will be there. But each mass M1, M2, M3, M4 is dm. And they are located at some distance r. This r is a variable, it's some function, and there are many terms, and when you have summation of many terms, each term is very infinitely small, then you make it like integration. You replace the summation with integration, and m1 plus m2 plus m3, that's the total mass. You can also put this as integral dm. dm1, dm2, dm3, all the dm's added together. So summation of all the dm's is integral dm. So this becomes your formula. So the summation is now replaced by integration. That's it. Very good, Gokulnath. Yep, excellent. Okay, I think my internet connection is fine. It shows green light. If any problem happens, I immediately get to know over there. Yeah, internet connection is fine. Yep, integral is just another name for summation. RVR Paninde, how to prepare for JEE Mains 2025? Very simple. Just like Gokulnath Bacha is a very young kid, and he is not even in 10th standard, and he is studying with us. So you just keep attending my classes of 11th and then 12th. You will slowly get to know the entire syllabus. Then you can give NTSC and other Olympiads, and by the time you reach 11th, you are already prepared. You already have that confidence. So as simple as that. Okay. Yep. So Irudov problem solving, Anirudh, I have conducted a course. Anirudh, I have solved all the 11th standard important problems of Irudov in that micro course. So please join the pro subscription and get yourself enrolled. And if you are already part of pro subscription, that is for free of cost. So Irudov problem solving, my problem solving, HC Verma, all problem solving courses are there. So instead of summation, all you have is integral. So just keep that in mind. So xcm will be integral x dm by integral dm, ycm will be integral y dm by integral dm, zcm will be integral z dm by integral dm. If you don't want to find individual coordinates in vector form as a concised way, you can write it like this. This m stands for the total mass, which is also integral dm. Let's see some question based on this. Now, yep, Aryan, I do teach on the Vedantu app. Hi Nirud, welcome. Nice to know it's your first time. Okay, so Ayush, I did the chain problem in work power energy without integration. So I would advise you to do one small thing. Probably watch the third or the fourth class of work power energy. I have done the chain problem where the chain falls or you have to pull it up. So there is a very simple trick without integration. Just watch it, you will understand it. Okay, it's towards the end of the class. Just do it. Okay. Let's try to find the center of mass of some object like a hemisphere. So what is a hemisphere? Hemisphere is nothing but you take a solid sphere, cut it into two equal halves. One half is called as a hemisphere. So the center of mass will lie somewhere over here. Okay, so let's say this is the y-axis. I want to find what is this distance from the base of the hemisphere. How do I find this out? Probably this diagram might give you some hint. Here is what I will do. I'll take this hemisphere and cut it into small, thin slices. Now everybody might have cut a potato. Yeah? Have you helped your mom or somebody in the kitchen? And what do? You take a potato, you first cut it into half. Almost looks like a hemisphere. And then you have two ways of cutting a potato. One is you make the slices like this. Usually this is what you do. Or when you're cutting an onion, you cut the slices like this. So each slice looks like a nice semicircle. How many of you have done this? Please let me know in the comment section below. Please let me know in the chats. How many of you have cut the potatoes like this? Yeah. But there is another way of cutting the potato. And what is that? The other way of cutting the potato is like this. Circles. Small, thin discs. Now, when you cut it into circles, you will get thin disc like this. Each disc will be of different radius. Think about it. Okay, it's like keeping disc over disc and of different radii. That's all. Oh, Anirudh, please don't cut your finger, man. Don't. No. I'm not asking you to cut your finger. Please cut the potatoes. And if you're not able to cut the potatoes and you cut your finger often, then please don't cut the potatoes. Please ask your mom to cut it, or your sister, or your brother, or your dad. Okay, so it's up to you. So now, which of the two options should I cut this hemisphere so that I can locate the center of mass? I can cut it like this, I can cut it like this. Now if I cut it like this, do I know the center of mass of a semicircle? No. But do I know the center of mass of a disk? Yes. The center of mass of the disk is at the center. So I know when I divide it into thin slices, each disk can be assumed like a point mass. So each disk will be like a point mass here, and I'll find the center of mass of all these points. Where is it located? That's all. Well, I cut it this way. I do not know where the center of mass is. So why do I want to create a new problem? I'll try to simplify the problem. So that's the reason why I had divided into thin disks. Great. I'm doing very good, Nisi 16. Welcome aboard. Yeah. Now you can very easily see if this is the x coordinate, if this is a y coordinate, and this is a z coordinate coming out of the board, the x coordinate of the center of mass 0, z coordinate 0, y coordinate I need to find out. So those of you who are worrying, sir, there are three formulas, x ke liye integral, y also has integral, z also has integral. Most of the times you don't have to evaluate two integrals. You just have to evaluate only one integral, because most of the times the other two integrals will be 0 because of the choice of the axis. Great. Now, how do I locate the center of mass? I have divided into thin slices. You consider one such slice. This is a slice, which is basically a disc, which is very thin. And this thin disc has a thickness dy and it is at a distance y from the origin. This point is the origin. Okay, this point is the origin. It is at a distance y and dy is this height. Great. Apart from that, I know one more thing. This disk has some radius. I hope you can visualize that. That disk has some radius. This is the center. This is your r and this is your y. Interesting. Now, I think I know the relationship between r and y as well. And you can see why I know that. Because if I draw this line over here is the radius of the hemisphere. Not the radius of the disk, the radius of the hemisphere. So this is r and this is our nice right angle triangle. So that means I know r square, which is the hypotenuse, is small r square plus y square. Maybe I might need it sometime, so I'm just showing that to you. Is that clear, my warriors? Everybody understood this? Yeah. So can we take the x component as r cos theta? Yes, you can take it, but there is no point taking the x component because I know the x coordinate is going to be 0. So I'm just worried about the y coordinate right now. Yeah. So Neeraj, I have already completed the term 1 syllabus, bacha, and tomorrow I'm taking up one short revision of the previous chapter. So I have already completed so many revisions and there will be more such revisions, and plus KVPY SX classes. So lot of things are coming up for you, bacha. Don't get disappointed. I'm there with you. Okay? Chalo. Now, here is the thing. This slice will have some mass. How much mass? dm mass. Why dm mass? Because it's very thin. Correct? Each thin slice, dy thickness, will have dm mass. How do I find out that dm mass? Let's think about it. dm mass will be density, because mass is density into volume, into d volume of the slice. Okay, interesting. What is the density of the sphere? It is same everywhere. It's a uniform hemisphere. So what's the density? You can take small mass by small volume, or you can take the bigger mass by bigger volume. What's the total mass of the hemisphere? Let's just assume it as m. What's the volume of the hemisphere? Total volume is 4 by 3 pi r cube. Hemisphere will be 2 by 3. So this will be 2 by 3 pi capital R cube. Why capital R? That stands for the total radius of the sphere. Is that understood? Yeah, it's not 4 by 3, it is 2 by 3 because it's a hemisphere, half of the sphere. 4 by 3 is for the complete one. Next up, what is the volume of the slice? First of all, think how the slice looks like. It's like a thin disc. What is the disc? It's like a compressed cylinder. What is the volume of that cylinder? What is the volume of that slice? What is the volume of the disc? Think about it. This is the radius r. This is the thickness dy. What will be the volume of that thin disc? What is the volume of the cylinder? Area into height. What is the area? Pi r square into height. It is dy. Everybody clear about this? Such an interesting thing. So it's a thin disc. Disc is nothing but like a cylinder. Cylinder volume, it's area of the circle into the height. So area is pi, small r, be careful, it's small r, square into dy. Great. Oops. Now, I don't think I want this small r because I have dy, so I will replace this small r with y. How do I do that? Let's try this out first. First of all, this pi and this pi goes. Okay. This 3 comes on the top, so it will become 3m divided by 2. I have r cube below. This small r square, I can write it as r square minus y square. So I'll write it as r square minus y square into dy. So that is dm. So I have found out dm in terms of dy. Why do I need to do that? Here is the logic. See, the y coordinate of center of mass will be integral y dm divided by total mass. I cannot integrate this because I can integrate y dy. I can integrate y cube dy, but I cannot integrate x dy. The variables always have to be same. So I need to convert y into m or dm into dy. Did you get the catch? I cannot integrate this. I cannot right now. I have to convert it into the same variable. So what I did, I converted dm into dy. You will learn this with practice. It looks scary right now. Everybody feels scared when you see this kind of integrations initially. But you ask a 12th standard passing out kid or a kid who is in 12th standard, for them it becomes very familiar. So this is the first time you are seeing it, so don't get disheartened or demotivated. Just stick with me. Okay, my warriors, let's do this. So fast. I'm not very fast. I'm very slow, bacha. I'm very slow, so that everybody understands this, Arnav. Yeah, because understand, there are so many kids who are learning or seeing this for the first time. Now, what you need to do is that just substitute the value of dm from here over here. But remember, 3m, 2r cube are constants. So bring those things outside the integral. So 3m by 2r cube is outside the integral. This is divided by m. And here you have y dm. So this all will be remaining. So I have r square minus y square, and this y is also there, and this dy is also there from here. The limits of the integration. What will be the limits of the integration? Think, the largest disk will be at the base. The y coordinate will be 0. There will be so many disks. The largest disk will be at the base. Y coordinate will be 0, and the smallest disk will be on the top. The y coordinate will be capital R. So the limits will be from 0 to capital R. That's it. Now this m and this m, you can see, will get cancelled. So I am left with 3 by 2r cube. Okay, and here you have integral. R square is outside. I just have y dy from 0 to r plus, minus, I have y cube. Oh, that's inside the integral. So y cube dy, and that's from 0 to r again. So let's see, what do we get? 3 by 2 r cube, and here we have r square integral y dy. Use the formula x raised to n plus 1 upon n plus 1. You will get this as y square by 2. That means when you put the limits, you will get it as r square by 2 minus y cube's integral will be y raised to 4 by 4. So when you put the limits, you will get it as r raised to 4 by 4. Now you can see r raised to 4 is common. So you will see 3r raised to 4 by 2r cube, and here you will have 1 by 2 minus 1 by 4. 1 by 2 minus 1 by 4 is nothing but 1 by 4 itself. So r raised to 4 r cube gets cancelled, and what you will be left will be 3r, one of the r on the top. 2 into 4, that's 8. So 3r by 8. That's the final answer. That's it, done, done. Okay. So Anakali Kai, so listen to me very carefully. I have already completed integration some 2-3 months back. I also conducted a revision class. You just go to the playlist. It's there on our channel. Watch those 2 lectures of integration plus the revision. 2 lectures of derivatives plus revision. You will understand it. Nobody in this world or universe can teach you integration and derivatives in one step or in one lecture. If they are trying to teach you, they are fooling you. They are probably making you think that you will understand, but you will not understand it. Okay? Yep. I hope this is clear. Yes, students Janice from crash course can also score very well. In fact, last year so many students in our crash courses scored so well. There was such a big delta. There was such a big change before joining and after joining. So students who joined us after first mains attempt and then after the third or fourth attempt had a big massive change just because of our courses. Okay, chalo. Let's see the remaining formulas. Okay, so I just told you for a solid hemisphere it's 3r by 8, but if it is hollow hemisphere it is r by 2. How will you get all these numbers? You will get all these numbers via integration. It's all there in HC Verma. Watch it. And if you still don't understand it, or if you still find some of the derivations are missing, I have conducted a derivation micro course exclusively for 11th standard students. It's all there for free on our pro subscription. So if you are a part of pro subscription, you can just go ahead to the derivation micro course by Shreyas Sir, and you will get each and every derivation, so you will never get stuck. Okay, and for solid cone, it's h by 4. hollow cone h by 3. Do you have to remember it? Yes, you have to remember it. You have to. Okay. The other formulas which you need to remember, see, these formulas most likely you will find it in most of the books. These are the two formulas which you will generally not find even in HC Verma. Now, what is this? Imagine this is a pizza. What is this? Pizza. Okay, this is a slice of a pizza. The radius of the pizza is r. Angle of the pizza slice is alpha. Okay, so this is a sector. Somebody ate the pizza, only the crust is remaining. That's an arc. So this is the arc. Angle subtended theta. Radius r. I hope this is clear. So when you have an arc, only this much part is there. Please understand. Only this much part is there. This is just an arc. Then the center of mass of this part obviously will be somewhere here. Correct? This is where the center of mass will be. This distance which is there. Okay, this distance. That distance is given by r. Okay, this is small r in this case. Sine theta by 2 divided by theta by 2. Very, very important formula. R sine theta is the total angle. Okay, so this is the total angle. Sine theta by 2 divided by theta by 2. This is the distance of the center of mass from the center of the circles or the arc's center. But if it is a sector, that means this entire thing is full of masala. Okay, it's a uniform mass. Then the center of mass will be slightly more inside. And let's say this is the distance of the center of mass. That distance now will be given by very similar formula. R, the total angle was alpha, sine alpha by 2, alpha by 2. There is only one small change between these two formulas. For a sector, it's more inside because there are more masses towards the center. For an arc, only the masses are on the periphery. So you multiply it by a number less than 1 to bring it closer, and that number via integration comes out to be 2 by 3. So this is the formula. So keep both these formulas in mind. Hello Satyam. Krishna, topics like current, electricity, EMI and all the 11th standard topics still rotation have very high weightage, including center of mass, projectile, all of this have very high weightage. Okay, so 2r by 3 sine alpha by 2 by alpha by 2 and r sine theta by 2 by theta by 2. Okay, let's see if we can solve this question coming up on your screen. Yep, we can use half angle formula, yes, but most of the times they give you good values only. But in case you want to use some trigonometry, definitely if the need arises, please use the trigonometry half angle formulas. Definitely, Gokulnath. A uniform wire of length 2 centimeter. This is 2 centimeter. It is bent to form into a circle. How much does the center of mass shift by? Let's see how many of you can do this. Hi Silparuka, Srikant, welcome aboard. Okay. So Santwana Dange, if I have started my preparation now, which all chapters to do? I'm done with kinematics. So Santwana, I would advise you to watch my lectures on relative, 2D projectile, and then go to Newton's laws, friction, it's all there in one chapter. Then it's the next chapter would be work power energy, and then circular, and then this. Okay, try to complete it in the next maybe 3 to 4 weeks. Okay, somehow, because if you do not try to complete it in the next 1 month, you won't be able to do it in one week. Okay, it will take 4 weeks or so. Then you will never get time for seeing the other chapters. So do not keep your backlogs prolonged for a long time. It's okay. Just try to do it. Trust me, you will understand it in a very fluidic manner, very simple manner if you watch it through my lectures. Okay. Yeah, Sandhana. I'll tell you one drawback of 11th standard physics. Everything is dependent. If you don't understand Newton's laws, you will not get work power energy. If you don't get work power energy, you won't be able to solve problems on collisions. If you don't understand center of mass, you will face problem in momentum. If you don't understand circular, you will face problem in rotation. If you don't understand relative, you will not understand pseudo forces, non-inertial frame. If you don't understand kinematics, you will not understand relative. If you don't understand vectors, you will not understand 2D. So that's how it is. So everything is dependent and relative to each other. Okay, chalo. Malvika and Raj, very simple. Every day, try to first of all recollect tables. Okay, try to say all the tables, square roots, everything. Number 1. Number 2, never use calculator. Number 3, make sure that you meditate and concentrate on the problem and try to do mental math. Okay, maybe you can start with maths on paper or calculations on paper and slowly move towards mental math. Slowly you will see your speed will increase. Just try to do these 3 steps what I told you, and you will see maybe in the next 4 or 5 months there will be a significant improvement in you bacha. Okay. Yes, Tamil I am. I did my research from IIT Bombay. I did my graduation from NIT Nagpur. Okay, so the correct answer is actually A, and let's see why is the answer A. See, my warriors, the length of the wire is 2 centimeters. This is 2 centimeters. So you bend it into a circle. Let's say the radius of the circle is R. So the length of the circle will be 2 centimeters. The length of a circle is 2 pi R. So therefore, R will be 2 goes 1 by pi. Now think about it. Earlier, the wire was like this. You bend it. So the wire center of mass was here. So when you bend it into a circle, the new center of mass will be here, right? So the question is, what is the shift? So what will be the shift? The shift will be the radius. So which is 1 by pi, and hence that's the answer. So from there, it has gone here. I hope that makes sense. Yep, correct, Rakesh. Very good, Dakshin. Excellent, my warriors. Moving on to the next question on non-uniform rod. For a uniform rod, we all know it is at the center, which is L by 2. Now, this rod is very special. The rod's linear density lambda varies as 2 plus x. Then the position of the center of mass of the rod is. Some options are given. I don't think we should worry too much about the options, okay? So don't look at the options. It won't be needed. Let's see how to do this. First of all, this is our rod. Linear mass density. What is the meaning of linear mass density? Linear mass density means mass per unit length. So basically, this is in kg per meter. Per meter, how much mass is there? But this is a function. It is not constant. It's not a uniform rod. That's the problem. So if lambda is 2 plus x, lambda is 2 plus x, lambda is mass per unit length. So it is basically dm by dx is 2 plus x. That's what it means. Okay, it's mass dm per unit length dx. So if I take dx, how much mass is there? Dm by dx is lambda, kg per meter. Now what is this dm? What is this dx? Let's try to represent it on this rod. So if I take a small section whose width is dx, okay, whose width is dx, maybe it is at a distance of x from this point, let's say this is the origin, then the mass of this slice is now called as dm. So dm is the mass of this slice of width dx, which is at a distance x from one end of the rod. As simple as that. Let's see what is the formula that we need. So x cm will be integral. Do I know the total mass? I think I don't. So integral x dm divided by integral dm. Okay, so I need to perform 2 integrations. So let's see how do I do that. First thing is very clear. If I shift dx over there, I'll get dm is equal to 2 plus x, okay, into dx. Now, what I can do, I can integrate both sides. Integral dm, integral this. So integral dm will be equal to integration of this. So 2 plus x, so split it. So 2 is outside, just dx comes inside, plus integral x dx. What will be the limits of integration? The length of the rod is 3 meters. So the value of x will start from 0 and will go till 3 meters. So x starts from 0 till 3. So then I'll get the limits. So 0 to 3, 0 to 3. So therefore integral dm will be, integral dx is just x. So it will be 2 into 3. Okay, just put x as 3 plus x dx integral is x square by 2. X put it as 3. So it will become 3 square by 2. So it will become 6 plus 9 by 2. 2 6 are 12. 12 plus 9, that's 21 by 2. So I think I got dm. That is 21 divided by 2. Very interesting. But the only thing remaining is integral x dm. So dm is 2 plus x dx. So integral x dm, so instead of dm, okay, instead of dm, what you are going to put? You are going to put 2 plus x dx. So x is as it is. Only thing I am replacing is this dm. So that dm will be 2 plus x dx. Again the limits will be from 0 to 3 because x starts from 0 and ends at 3. Everybody clear? Everybody clear? Even if you don't know head and tails about integration, it's okay. Just observe. Watching it will probably make you register certain things about integration. So when you watch the integration lecture, then you'll be like, Acha, this is how it has to be done. You know, a lot of people give up because they don't understand one small thing or two or three things of a particular solution or theory, and then they start losing interest. But never do that. Even if you don't understand few things, put in your full faith, put in your full concentration, and try and understand. Few things you will not understand, it's okay, but eventually you will, and then you'll realize, acha, this is what sir was doing. Oh, this is how it is done. And that's when you'll get confidence and you will not have backlogs. Okay, moving on. So what do we have over here? This 2 goes on the top, 21 comes below. Okay, so this 2 goes on the top, 21 comes below. And what do we have over here is, okay, 2 is outside, integral x dx plus x square, integral x square dx, and the limits are 0, 3, 0, 3. That's all. So this will become 2 by 21, and this will become integral of x dx. How much it is? X square by 2. That means it will be 3 square by 2 plus x square dx integral is x cube by 3. So put x as 3. So 3 cube by 3. Okay. So what am I going to get? Well. This 2 gone. This 3 and one of the 3 gone. So it will become 3 square. 3 square, I'll take it outside. So I'll get 2 into 3 square and divided by 21. And nothing is left inside. 1 is there. And here also 1 is there. So this will become, okay, one of the 3 will go. So 2 into 3 divided by 7, because 7 into 3 is 21. And 1 plus 1, that's 2. So 2 into 3, 6. 6 into 2, 12. 12 by 7, that's the answer. Done, done. Is that clear? Thank you, Palak Bacha. It means a lot. So, thank you, Neeraj. Yep. Very good. Excellent day. May I know the next chapter that you're going to teach in Pathfinder series? Pranesh, right now the Pathfinder series term 1 syllabus is over. Right now I'm conducting the revision. I completed all the chapters of term 1. So right from electrostatics, magnetism, and AC, EMI, everything is done. Now I'm continuing the revision. I'm doing one shots, and after that I will also start with the term 2 syllabus. Okay, is that clear? Very good, Gokuldas. So what a beautiful integration. So you can see a beautiful application of integration out here in physics. The answer was 12 by 7. Moving on to the next type of problems. Okay. So RVR Paninde, it's very simple. If you are motivated, you will be active for a very long time. That's it. If you don't have that motivation, then you will not be activated. So find that motivation, you will stay active. As simple as that. Addition rule and subtraction rule. It's very simple. See, if you know the center of mass of one object somehow, and you know the center of mass of the other object, let's say a square example, then the center of mass of the combined object can be found out very easily. All you need to do is add both of them, and that's it. But when I say add, all you need to do is, let's say you have to find the center of mass of this combined body. So first of all, you have split it up into a circle whose center of mass you know, and a square whose center of mass you know. Then I know the center of mass of this guy is here, center of mass of this guy is here. This is m1. Let's say it has some coordinate x1, and let's say this is m2. Let's say it has some coordinate x2. So the total center of mass of this entire object xcm will be m1 x1 plus m2 x2 divided by m1 plus m2. As simple as that. So all I have done is considered this like a point mass, considered this like a point mass, m1 and m2, and together their center of mass will be somewhere over here maybe. This is where the center of mass is. As simple as that. So treat each object like a point mass and then use your standard formula. Is that clear? Very, very easy. That's what you do for addition. The same rule also applies for subtraction. You take out somebody which has a cavity. So you might have seen some objects which has hollow or which has a cavity or something is scooped out. In those cases, use the subtraction rule. Let's say, this looks like a SIM card. Somebody has punched a hole in it. This object is technically this complete object minus a small sphere or a disk which is taken out. Yep, definitely Arnav. I'm going to do that cavity problem. Whenever you have such a thing, what you need to do is, let's say you want to locate the center of mass of this. What you do, you know the center of mass of the entire thing. Let's say this entire thing is over here. Let's say it is M1. Okay, so this is the center of mass of this guy. You know the center of mass of this cavity. Maybe let's say this is a circle. Let's say it is over here. Now, this is M2. This is the one which is taken out. The center of mass of the remaining part, XCM, will be M1x1, which is basically present, minus M2x2, which is basically removed. Can you see what is removed? Upon M1 minus M2. Okay, whatever was present before removing it, this was present before removing, okay, present before removing, minus M2x2, what is removed, upon M1 minus M2. Just use this formula, it becomes very, very easy and simple. Let's try to do two problems on this. One is addition problem, and then let's do a subtraction problem. You will get the gist of this. Okay, only when you solve problems are you going to understand it. Let's try this out. Here we have a question. These kind of questions are common in KVPY and in JEE Mains and even in NEET. So uniform disk of certain radius 1 centimeter is put over another disk of radius 2 centimeter of same thickness and density. The peripheries of the two disks touch each other. What is the position of the center of mass? That's the question. Let's see how to do this. Okay, come on, let's do this. Okay, this is how it looks like. Look at the diagram first of all, my warriors, and look at the question which says clearly that the peripheries of the two disks touch each other. The red one is of 1 centimeter, the grayish one is of 2 centimeters. The peripheries are touching each other. The smaller one is kept over the other. Which one will you use? Which of the two methods will you use? Will you use addition or will you use subtraction? Obviously, you are going to use addition method. Makes sense, my warriors. You have to use addition because you are placing one disk over the other disk. Fair enough. Okay. So, this disk over here, okay, this disk over here has a center of mass exactly over here. Let's say I call this as M1. This disk, the red one, has a center of mass over here, and the bigger one has a center of mass exactly over here. Think about it. Fair enough. Let me also mark the x-axis and y-axis. This is my x-axis, and let's say this is your y-axis. So this is your origin. Now read the question carefully. The disks have same thickness and density. Now that means if they are made of the same sheet, same thickness, same material, so their masses will be proportional to how much area they occupy. Imagine I give you a sheet. Okay, this is a big sheet. I tell you, carve out a shape out of this, carve out another shape out of this, carve out another shape out of this. All these three things may have different masses, but their masses, whatever mass you see over here, this mass will be proportional to the area which you carve out. Everybody is agreeing to this? Yep. Now, if this is clear, the area is the mass is proportional to the area. Think this M1 will be proportional to the red area, M2 will be proportional to the whole gray area. Makes sense? Everybody? Everybody, is it clear? So if the mass is proportional to the area. Oh, these are circles. Circle's area is nothing but pi r square. So it is basically proportional to r square. So I just got this. The mass is directly proportional to r square. So think about it. M1 has a radius of 1. So if M1, if I assume it as M, M2 will be, think about it, the radius of the big one is 2 centimeter. 2 square is how much? 4. So that would be 4 times of M. Is that understood? Think about it. Is that understood? Everybody? Oh, sorry, I'm not eating silk today because I just had my dinner before this class, because I know this is a big class, this is a marathon class. It will be more than 2.5 hours. So yes, I came prepared by having my dinner. Okay, is this clear why M1 is M? Then M2 will be 4M, because M1 will have a radius of 1 centimeter and this has a radius of 2 centimeters. So 2 square is 4. It's proportional to 4. Is that clear? Clearo? Understoodo? Excellento? Oh, Chitra, you cannot see any options, is it? Everybody is able to see the options. I have put up A, B and C and D. You should be able to see all the options. I don't know why you're not able to see. Just hit the screen little bit over there. Maybe it will work. Probably when you hit the screen little bit, sometimes you will start seeing the options. Sometimes, you know, the LCDs don't work over there. Oh, Harita, there is no option. Just hit the screen. Just punch it little bit over there. Okay, it will work. Probably, most likely. Okay, just try this out. Okay, now you just use your addition formula. So XCM, I am writing on the options. Okay, so XCM will be M1 X1 plus M2 X2 divided by M1 plus M2. So let's try this out. What is M1? M1 is M1, but I have assumed it as M. Okay, fair enough. X1. X1 is the coordinate of this point from here. The radius was 1 centimeter. A small disc, 1 centimeter. So this one over here, I hope you realize this is 1 centimeter. So the coordinate is 1. Fair enough. Plus M2. M2 is here and it is exactly at the origin. M2 is 4M. It is at the origin. So the x coordinate is 0 upon M plus 4M. Is that clear? Now M plus 4M. Oh, that 4M is going to get multiplied by 0. So it's going to become 0. So I'm just going to get M by 5M, which is nothing but 1 by 5 centimeters. So that's XCM. Done, done, done. So from the center of the bigger sphere, the center of mass is 1/5 of a centimeter on that side. I hope this is clear. Very good. Okay. Okay, very good. Very good. So that's the answer. Okay, is that clear? Very good. Finally, I am able to see you live. Thank you, Mudali. Thank you. Welcome. Yes, Gokulnath. I was doing a joke. Okay. Chalo. Yes, Satyam. It's option B. That's it. Now let's do a question on removal, the subtraction. On subtraction. Okay. So from a sphere, you take out a smaller sphere of radius 1 meter. So how much is the center of mass going to shift by? These are the options. Just ignore these options. Let's just try to do this. Okay. So here is what we have. We have a big sphere of radius 2 meters and then 1 meter sphere is removed. Exactly like the previous problem, but this time it's subtraction. So the question is, how much does the center of mass shift by? Okay. So first of all, let's take this as the origin. This is our y-axis and this is our x-axis. This is the origin. This is where the center of mass was originally, before. This was the old center of mass. Now, the center of mass will probably be here somewhere because you have scooped out something. Center of mass will shift. Let's try to find that out. I'll see what is my M1 and M2. So my M1 is the big one. So my M1 is that big sphere. Okay. M1 is that big sphere. Okay. So this is my M1. Okay, and the center of mass will be obviously at the origin. This is where the center of mass will be for the big one. From this, I am taking out a small sphere. Okay, so again, these are the coordinates. Okay, the center of this M2, the center of mass will be somewhere here. again, since these two spheres are from the same material, again I can use the fact that mass is directly proportional to volume. And what is volume proportional to? It is proportional to radius cube. So basically I just found this out. Mass is proportional to the cube of radius, because mass is proportional to the volume. These are all spheres. So think, the smaller sphere has a radius of 1 meter. That means if I assume m2 as m, the radius of the bigger sphere is 2. So cube of 2 is 8. So m1 will be 8m. Is that understood what I just did? If this sphere has a radius of 1 and this has 2, the volume will be proportional to 1 cube, this will be 2 cube. So if this is m mass, this will be 8 times more. As simple as that. Very good. Akshay, it's very simple. If you're a part of Pro subscription, just go ahead and search HC Verma Solutions. You will get my course. Okay, very simple. Okay, so now you can see it will mention conducted by Shreyas Sir. If you still are not able to get it, leave a comment after the video ends. I'll explain you the procedure in detail again, okay, step by step in the comment section. Just leave a comment. Okay, so let's see what to do now. First of all, I found out m1, I found out m2. Let's use our formula. What is our formula? XCM will be m1 x1 minus, why? Because I'm subtracting, m2 x2 divided by m1 minus m2. So what is m1? m1 is 8m. What is x1? Coordinate of this big sphere. Center of mass is exactly at the origin. So x coordinate is 0. So just put 0. Minus m2. What is m2? m2 is m. What is x2? Coordinate of center of mass of this guy. I just know this much is 1 meter because that is the radius of the smaller sphere. So just put 1 over here divided by m1. What is it? 8m. Minus m2. What is it? m. 8m into 0? 0. Minus m divided by 7m. So this will be minus 1 by 7 whatever meters. So that's the answer. XCM is equal to. So earlier it was here. Now it has shifted by 1 by 7 meters. Yep. Yeah. Satyam, you don't have to remember that formula like that. No, that is not the correct way of doing it. No, md upon m plus m, that's wrong. No, that will not give you the correct answer. यहाँ पर वो work नहीं करेगा. 1 by 7 meters. Let's go to the next part. Yes. Do we have a class on collision tomorrow? No, Anil. I think it's day after tomorrow or something. Tomorrow there is a KVPY SA class. KVPY mock test number 2, and then I think day after tomorrow or something you'll probably start with collisions. Okay, if you have any doubts, use our Vedantu app, ask any doubt by taking a picture, and you can chat with our doubt experts, unlimited number of questions. You can also ask for hints, you can also ask for doubts like, is this solution correct or is there any mistake in this solution? So all of this for free. So that's the power of Vedantu app. Okay, so if you are in Pro subscription and if you did not know about this, please use that. Now, Tamil Technical I'm also teaching for NEET Pro subscription bacha as micro courses. So there are lots of my micro courses which are available both for JEE as well as NEET, like the HC Verma, derivations and all of that. Okay. Hi Esther, long time no see. If we compare it with our formula of mass comes out to negative, how come? Please explain. The coordinate has come out to be negative. Neeraj, minus sign signifies it has the coordinate is not on this side, the coordinate is on that side. The mass is not negative. Coordinates can be positive or negative. I hope that is clear. Yes Satyam, kal main KVPY karwaunga. Are you guys now ready for motion of center of mass? Come on. This is the last part of center of mass. Motion of center of mass. Are you guys ready, my warriors? Hi Meera, welcome aboard. Yes, Gokulnath is always ready. Gokulnath, I was seeing your lecture the other day. Excellent, very good, bacha. You're extremely proud of you. Okay, Harita is ready. Kushagra ready. Anna Malaike ready. So there are 78 hours, one shot on JEE channel and 0 to advanced without prerequisites. I'm not sure, Kushgara, about that. Okay, which book I should read after seeing my lecture? Meera, you should read from HC Verma. Okay, my research topic is control systems and measurement, in, you know, solar panels and all of that. Yep. Okay. Mass of a ghost can be negative. Very good, Rakesh. Today your level of jokes has increased to the next level. It's like you sat in a rocket, you put your jokes level in a rocket and it's suddenly boosted up. Very good, proud of you. Very nice. Okay, let's get moving and let's talk about motion of a center of mass. Now, why is this rocket here? Have you seen the complete launch of a rocket anytime? The rocket goes up and it breaks into pieces. One part falls here, one part falls there. Sometimes a missile hits something and it breaks into pieces. Now, when a rocket or a missile or any plane or anything just flying and it breaks into pieces, each part will go in different directions. But you will see the center of mass will still continue the journey as if nothing has happened. If you played Angry Birds, there was one bird where you shoot, it lays an egg. It lays an egg, that egg falls and that bird goes flying up. So that bird with that egg, it flies till a point, then you shoot, then the bird goes somewhere, the egg goes somewhere. But the center of mass of the bird still continues the journey as it would have had the bird not laid the egg. Or I can also say, if the rocket blasts and it breaks into pieces, you will still see the center of mass will continue the same journey as if the rocket has not blasted, and however it would move, it would continue its journey. What is the reason behind it? So for that, let's understand the motion of center of mass. The first thing, oh, look at this. This is also a beautiful example. And this guy is throwing a V-shaped object or an L-shaped object like that. Observe this very carefully. Very interesting thing out here. Okay, you can see that the object, all right, is moving, it's rotating, and the center of mass is translating. Each point is moving in different directions with different speeds. So we can also find out the velocity of the center of mass. So we are going to study the motion of how exactly the center of mass moves. It's a beautiful example of that. Each particle moving in a very different manner, the center of mass continuing its translational journey. So for that, the first formula which is there on your screen, and here it is. First thing, if you know the velocity of each point mass, okay, let's say there are masses m1, m2, m3, m4, the center of mass will be somewhere here. The velocity of the center of mass, because each particle is moving, will be given by same formula what you have studied before. It will be m1 v1 plus m2 v2 plus m3 v3, the whole thing divided by m. As simple as that. Does it resemble your standard formula for position of center of mass? And yes, you can see it closely resembles that. Instead of r or instead of x, you have velocity. It's as simple as that. Very good. Okay. क्या मैं एंग्री बर्ड खेलता हूँ? Yes, I play with very angry birds and they also get very angry with me, and then they come and pluck my hair when they get really angry, and that's why I lost few hair last time I played with angry birds. This next time I'm planning to play with angry dogs and angry pigs. Let's see what they do. I hope they don't bite me. A lot of people get bitten by dogs. I don't know if there is anybody who has got bitten by pigs. I don't know. How will it be? Okay. So, acceleration of center of mass. Acceleration of center of mass is m1 a1 plus m2 a2 plus m3 a3 divided by total mass. So, if each point mass has some acceleration a1, a2, a3, a4, the center of mass ka acceleration is given by this formula. Very simple. If you know position of center of mass, if you attended my first part, you also get to know the next part of the class. Okay, great. And the last formula, momentum of center of mass. I know what you guys are thinking. Momentum, if particle 1 has momentum p1, particle 2 has momentum p2, particle 3 has momentum p3, the momentum of the center of mass is given by, it's not m1 p1 plus m2 p2 upon m1 plus m2. No, it is just given by the total momentum of the system. That's all. So let me just show this to you. See, velocity of the center of mass was m1 v1 plus m2 v2 plus mn Vn, the whole thing divided by m1 plus m2 plus mn. Now take this guy over here. You will get total mass into VCM will be m1 v1. What is m1 v1? It is momentum 1. m2 v2, that's momentum 2. Like that, the nth term will be momentum of nth particle. What is m total into VCM? It is the momentum of the center of mass. Total mass into velocity will be momentum. P1 plus P2 plus P3 plus Pn will be the momentum of the system. So the momentum of the center of mass is the total momentum of the system. As simple as that. It's not m1 p1 plus m2 p2 plus m3 p3. I hope this is clear. Yeah. If momentum is 0, does it mean that the kinetic energy of the system is also 0? Well, if the momentum is 0, Neeraj, then the total momentum, if it is 0, that means the center of mass is at rest. But that does not mean each particle is at rest. Maybe one particle is going there, other particle is going here. So they cancel out and their center of mass stays at rest. So the total momentum might be 0, but each particle might be in motion. That means their total kinetic energy might be there. So it is not necessary for the kinetic energy to be 0. Okay, let's move to some questions based on this concept. And here is the first question. Let's see who is the quickest to give this answer. Two particles, each of the same mass, move due north and due east, respectively with the same speed of √2. The magnitude and the direction of the velocity of the center of mass is, come on, let's see how many of you can get this. Come on, my warriors. All right, come on, Roshni, come on, Rakesh, come on, Chitra, come on, Prajit, come on, Suchi, come on, Kavita, come on, everyone. Oh my God, very good, Prajit. Nice to know that. All right, hi, Patikal, Ashwit, Krishna, nice name. All right. Chalo, let's see if you can solve this question. Done. Let's do this. Come on, my warriors. Okay, chalo, let's draw the diagram first. And what do we have over here? There is one mass which is moving with √2 meters per second. And there is another mass m and it is moving east with again √2 meters per second. So the question is, their center of mass will obviously move somewhere here. What is the velocity of the center of mass? Well, that's easy. V bar Cm will be m1 v1 bar plus m2 v2 bar by m1 plus m2. What is m1? m1 is m. What is v1 bar? v1 bar is just, √2 j cap plus m2 is just m. v2 is √2 I cap upon m plus m. m goes, 1 plus 1 is 2. So it will become √2. I can put I cap first and then I can put √2 j cap. 1 plus 1, like I said, is 2. So this will become 1 by √2 I cap plus 1 by √2 j cap. So that is the velocity of center of mass, but the magnitude of that modulus will be root of 1 by √2 square plus 1 by √2 square, which is 1 by 2 plus 1 by 2, which is 1. Root of 1 is 1. So 1 meter per second northeast, because that's the direction. Something I cap, something j cap, same I cap, same j cap. That's northeast direction. Very good. Option B is the correct answer. Excellent, warriors. Moving on to the next question coming up on your screen now. Wow, what a question. Very good, Neil Kamal. Nice. Excellent, Rasika. Very good, Chitra. Two particles of equal mass have velocities 8i and 8j. First particle has acceleration 5i plus 5j. The second particle has no acceleration. The center of mass of the two particles move in a path which is given by. Very interesting question. Let's try to do this. First, V1 and V2 is given. So let's try to find VCM. VCM will be m1 v1 plus m2 v2 upon m1 plus m2. This is all bar. So VCM will be m1, the masses are equal. So m into v1 is just 8i cap plus m2 is also same. v2 is just 8j cap. m1 and m2 both are same, so m plus m. So this will just become 2. 8 by 2, 4i cap. 8 by 2, that's again 4j cap. So that's what I get VCM as. Fair enough. let's also try to find out what is ACM. Maybe knowing what the acceleration and velocity is, maybe I'll be able to figure out how their motion is. So let's just try to figure this out, nothing else. So ACM will be again m1 a1 plus m2 a2 upon m1 plus m2. So m1 is m, a1 is this one, so it is 5i plus 5j plus m2 is again the same mass. The second acceleration is 0, so 0, the whole thing divided by m plus m. M goes, so 5 by 2, because 1 plus 1 is 2, is 2.5 I cap, 5 by 2 is again 2.5 j cap. So this is acceleration of center of mass. Now what does this tell you? See, try to understand this. 4i and 4j will be somewhere like this. This is velocity of center of mass. 2.5 and 2.5j. Tell me one thing, will this acceleration be parallel to the velocity or not? Think carefully. 2.5i and 2.5j. 2.5i and 2.5j again will be in the same direction. Think about it. Because their x and the y components are equal, so the angle which they make will be exactly 45 degrees. So if velocity and acceleration are in the same direction, what will happen? This particle will always accelerate in that same direction. So this particle will continue to move like this. And what is this? This is a straight line. If the acceleration made an angle, then it would go in a curved path. But right now it is not making an angle. It's accelerating in the same direction as it of the velocity. So that's why it's a straight line. Else it would have been a parabola. So this is a straight line. By chance, for example, the velocity came out to be like this. And let's say, for example, the acceleration came out to be like this. Okay, this was the acceleration. Then you would see that the velocity will change the direction, and that would have been a parabola, provided this acceleration is constant. If this is constant, just like the motion under gravity. Gravity's acceleration is constant, so the motion is a parabola. So if acceleration is constant, it's not a function of time, then you will see it would have been a parabola. But right now it is not. I hope that makes sense. Yep. Is it clear? A lot of people make this mistake and they write it as a parabola. So this is one thing which I wanted to mention to you. Alright, straight line is the answer. Next question, very tricky question. Let's see how many of you can do this. There is a man of mass. How much mass? Look at that. 80 kg. He is riding on a small cart of mass 40 kg, which is rolling along a floor, level floor at a speed of 2. He is running on the cart so that his velocity relative to the cart is 3 in the direction opposite to the motion of the cart. My goodness, that's where you need relative motion. If you have studied relative motion under me, then you will get this very easily, else you will probably get a wrong answer. Let's draw the cart first. So this is my cart. Okay, this is my cart. And what is the mass of the cart? It's a level road. That's what is mentioned. Okay, what is the mass of the cart? Which is rolling on a level floor at a speed of 2 meters per second, and the mass is 80 kg. So this is 80 kg, and this is moving at 2 meters per second. Now there is a man. We'll assume him as Pandu. So Pandu is there over here. He is Pandu. Okay, he is Pandu, and he is running. Okay, he is running. And he is running on the cart so that his velocity relative to the cart is 3 in the direction opposite to the motion of the cart. Cart is going there, Pandu is going here. But the relative speed is 3. The relative speed is 3. Oh my god. Rakesh, car will break, the man is overweight. Oh, what is the mass of the man? 80 kg. Oh my god, he's 80 kg. Crazy. Achha. Think that speed 3 is relative to the cart. Imagine I am sitting on the cart. I move in 1 second 2 meters. Think of it like 2 steps. 1, 2. For the cart, the Pandu moves 3 steps behind. How much did the cart move? 1, 2. How much did Pandu move? In those same seconds of 1 second, he moved 1, 2, 3. So for the ground, that is you, how much did Pandu actually move? Quickly tell me. Quickly. Oops. The cart was 40 kg, is it? Oh, okay. Thank you for pointing it out. I read it as 80 kg for some reason. A man of mass 80 kg is riding on a small cart of mass 40 kg. Yep, this is 40 kg. Cool. Thank you very much. Thank you. Okay, thank you. Quickly tell me. Think. The cart moves 1-2 meters ahead. The Pandu moves 1-2-3. So for the ground, how much did Pandu actually move? 1 meter behind. So the actual speed of Pandu is 1 meter per second this way. Does that make sense? So always measure the speeds with respect to the ground frame for using m1 v1 plus m2 v2 or the same frame basically. So VCM will be m1 v1 plus m2 v2 upon m1 plus m2, always with respect to the same frame. Be careful. What is m1? It is 80. What is v1? v1 is 1 but left side, so minus 1. Okay, take care of the directions. Plus m2. What is m2? 40. What is v2? That's 2 upon m1 80 plus 40. 80 is negative, 40 into 2 80. Interesting, this is 0 upon 120. 0 upon 120 is 0, hence the answer is 0. Wow, what an interesting question. Yep, very good, Mohammed Sami. Okay, Sarthak. Bacha, I'll tell you something. The JEE paper is not animated. So when you see a problem of constrained motion or pulleys with many pulleys or a wedge or masses exploding, colliding, etc. in JEE paper, that JEE paper does not have that play button. The JEE paper does not have that play button. That means you have to visualize, and for visualization you might get very fascinated looking at those 3D. Oh my God, sir, so cool, sir, I got visualization, sir. But it is of no use. You have to create it on your own, in your mind. You should see around you that spheres falling, those objects colliding, atoms vibrating, electrons revolving around the nucleus. You should feel it around you. Only when you feel it around you, you will develop visualization. When you see a wall getting heated up, you should be able to visualize, oh, that wall is getting heated up. That means the molecules are vibrating, they are colliding, the electrons are getting hit by each other. That's how you should feel. You see current flowing, you should be able to visualize, you should be able to see how those electrons are moving from one atom to the other, jumping from here to there. That's when you develop visualization, bacha. Correct? That's what you need. Okay? Great. You should thank Pandu for helping us solve the problem. Excellent. So the answer is 0, and let's move on. The last theorem for today's chapter. Very true, Roshni, very true. Now comes the next question. Here we are going to explain what happens when something explodes and how does the center of mass move. So the theorem is like this. Net external force acting on many bodies together as a system. What is this? Particle 1, particle 2, particle 3, 4, 5, 6, n. All these particles are a part of my system. There is some force F1, F2, F3, F4, Fn acting on it. The total external force. What are these? I'll write it over here. Okay, I'll label it. What are these? These are external forces. What about internal forces? It might be there. Maybe these two might have some internal force as well. But I don't care about it. There might be internal forces between them as well. Only the net external force is the total mass. But this is whose acceleration? Acceleration of the center of mass. Very, 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 very important. I'll explain this to you. Observe. Imagine this was a bird. Okay, this is a bird. Okay, this is a bird. I hope this looks like a bird. It has two legs. Yep. It is also carrying an egg in its stomach. Okay, this is a bird. This is a beak. Okay, beautiful bird. Okay. Now there might be some force the bird is applying on the egg. There might be some force the bird is applying on the egg. Tell me, if I take bird and egg as a system, is the force which the bird is applying on the egg, is it external or is it internal? Come on, my warriors. Think about it. Think about it. The bird is flying. It's trying to lay an egg while it's flying. The force which the bird exerts on the egg, if you take bird and egg as a system, is it internal or is it external? Come on, my warriors. Very good, Roshni. Very good, Harita. I hope you are not remembering your morning scenes as I am talking about this problem. Okay, let's not get there. Okay. So now, when this bird, okay, I cannot draw the same bird. Sorry, that's my talent. Every time I draw a bird, it ends up being a new species. Okay, so it looks like a new bird, but let's just assume it's the same bird. Now that bird has laid that egg. Okay, so this egg has come out. So there was an internal force. There was an internal force on it. This was internal. Now, if you take this as a system, who is the external force? The external force is obvious. The external force is the total mass of the bird plus the egg into G. Here also, on the entire system, you will still see is the total mass of the bird plus the egg into G. Is the external force same before and after? Is the external force same before and after? Think about it, my warriors. Just because the bird has laid the egg does not mean that the external force has changed. It's internal. External force is still the same. If external force is still the same, my warriors, think about it. LHS of this equation is same. Total mass is same. LHS is same. Total mass is same. Acceleration of center of mass. Acceleration of center of mass should be same. Yes, the egg will break on your head, Satyam. Don't worry. So, move on the side. Be careful. Always look on the top. So, whenever you are walking on the streets, you should always look on the top. You never know which bird might lay an egg on you. And if it's a hot sunny day, you might just get an omelette on your head. Okay, that would be bad. Okay, so external force is same. Mass of the total system is same. Acceleration of center of mass is same. That means the center of mass of the system will continue its journey. It will continue its journey. The bird might go on the top, the egg might go here, the center of mass, which is outside the body, it will just continue its journey. That's it. It will not be affected. It will be unaffected by all these things. It's an internal force. So that's what this thing says. The net external force accelerates the center of mass. Internal forces have no role to play in this. Yep. When will be marathon session? Vicky, this is the marathon session, bacha. If there are multiple eggs released per minute, my God, Rakesh, this bird is like heavily pregnant. Okay, it has got like 4 eggs, 5 eggs. Then would it fly like a rocket? Yes, Rakesh, for sure. Let's say it's like producing quadruplets, just like Farrakhan did. Yeah. Like tuck, 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 tuck egg. Then every time that egg is released, the bird will bounce up like a rocket. The center of mass will continue with its journey because these eggs are going to apply internal force on the bird and the bird is going to apply internal force on the eggs. As simple as that. I hope this is clear. Very good. Thank you. Yeah. Okay. Now I have another question for you. Just imagine this. This bird is not flying. It's lying coolly. Let's draw a cool bird which is just lying. Okay. I just don't know how to draw that bird. Okay. This is that bird. It's relaxing. Okay. It's relaxing. You can see. Okay. Oh my God, it looks crazy. It's looking like it's eating some insects on its feathers. Anyways, and there is this egg. Okay, this is the egg. Very good. This bird is lying coolly on a smooth floor. This floor is smooth as butter. And there are 2 forces on this. What are the 2 forces? External, come on my warriors. On this system, there is the weight. M plus M. One is the bird, one is the egg. The whole thing into G. Understood? Oh, clear? Oh, done? Oh, okay. There's one more force. What is that force? That is the normal. That is the normal. Okay. This normal will be equal to the weight. N and mg will cancel. There is no other force in the horizontal. Why? Because it's smooth. So can I say this external force is 0? Can I say this external force is 0? Is this understood? Oh, clear? Oh, very good. A branch of a tree. No, this is a smooth branch. You can think of it like that. Excellent. Now, if LHS is 0, RHS must be 0. But mass of the bird is there, egg is there. So what should be 0? Acceleration of the center of mass must be 0. Acceleration of the center of mass must be 0. Now if acceleration of the center of mass must be 0, my warriors, think about it. What will be the velocity of the center of mass? The velocity of the center of mass will not change. Acceleration is not there. That means velocity is same, it is constant. So velocity will be constant. Makes sense? It will not change. But what was it? What is that constant? Think carefully. The bird was just lying. It was just looking at the sky. It was at rest. So initial velocity of the center of mass was 0. Initial velocity of the center of mass was 0. If initial velocity of the center of mass is 0 and the velocity should remain constant, come on my warriors, what should be the final velocity of the center of mass? Think about it. That should also be 0. Correct? There is no negotiation in that. It is not negotiable. This has to be true. Final velocity of the center of mass has to be 0. Suddenly, this egg hatches. The egg wants to come out. The bird lays that egg. The bird lays that egg. This egg just pops up. Like put. This comes out. What will happen? The system will say, wait a minute. I have to keep my center of mass at rest. I cannot negotiate on that. Sorry. I will not negotiate on this. If this egg comes out like this, the bird will go here to keep the center of mass at rest. As simple as that. Is that clear, my warriors? A very, very interesting relationship. So net force is 0, acceleration is 0, velocity is constant, initial velocity is 0, final velocity is 0. So if the egg comes here, the bird goes behind the center of mass. So the egg is there, the bird is there, center of mass, it's still there. It's not moved. Very interesting. That's what has happened. Is that clear? Can I move ahead? Can we solve 2 important questions on this? Enjoying the class? If so, do not forget to smash the like button and hit the subscribe button down there. Let's move ahead. Very good. And look at this. This is another beautiful simulation of motion of center of mass. The entire external force is mg. The center of mass moves in the parabolic path. Other parts move in different ways. Very interesting. Very interesting. Okay, let's talk about some questions. And here we have 2-3 questions. Very true, Rakesh. Okay, Anushka. Okay, Krishna, Nanda. All right. Not that great, Vicky. All right. Okay. So here is the question. And what do we have? We have a question which says there are 2 blocks and they're tied to each other with a string. The masses move. One goes up, one goes down. What is the acceleration of the system's center of mass, basically? The center of mass acceleration. Okay. Let's find this out. One of them is 3, one of them is 2. Okay, let's say this is 3, this is 2. Heavier mass will obviously go down. Lighter mass will obviously go up. This is, let's say, A2. Let's say this is A3. I think we know how to find the acceleration. Acceleration of 2, magnitude wise will be acceleration of 3. Okay, magnitude wise. And what is the magnitude? It will be higher mass or pulling mass. Pulling mass, I had given you one shortcut formula. For pulling mass minus opposing mass or resisting mass, opposing mass upon total mass, the whole thing into G. So what is the pulling mass? It's 3. What is the opposing mass? That's 2. Total mass 3 plus 2 into G. So 3 minus 2, 1. 3 plus 2, 5. G is 10. Okay, 10 by 5, 2 meters per second square. Fair enough. So let's finally write down what is the acceleration of center of mass. It will be m2, mass of 2 kg, into a2, this is all vectors, plus m3 a3 divided by m2 plus m3. So what is m2? Mass of 2 kg, it's 2 kg. Acceleration of 2 kg, that's going to be 2 upwards, okay, plus m3 is 3 kg. Acceleration of 3, that's down 2, so minus 2. Do not forget that minus sign. Upon m2 plus m3, that's obviously going to be 2 plus 3. So what is it that I'm going to get? 2 2s are 4, 3 2s are 6, 4 minus 6, that's minus 2. So minus 2, 2 plus 3, that's 5. So minus 2 by 5 meters per second, or minus 0.4 meters per second is a second square. So that's the answer. That's how you find acceleration of the center of mass. Beautiful question. I hope you guys got it. Very good. 2 by 5. Yes, minus 0.4 meters per second square. Moving on to the next question coming up on your screen right away. Oh, is it? Galad, the term 1 examination dates are out. I'm going to announce it, Galad. Thank you for letting me know. I'm going to create a shot ASAP. Don't worry. A man of 25 kg standing at one end of the boat of length 25 meters and mass 100 kg. If he starts running, and when he reaches the other end, he has a velocity of 4. With respect to the boat, the final velocity of the boat is... Yes, Vicky, it is enough. Obviously, there's a JEE Mains and Advanced channel. Okay, let's try to draw the boat and the man. So this is our boat. Very interesting boat. And the boat has a mass of 100 kg. Interesting. And there is this Pandu, all right, this is this Pandu, is at one end of the boat. His mass is 25 kg and he goes like this and his velocity is that way. So when he reaches the other side and he has a speed of 4 meters per second with respect to the boat, what is the velocity of the boat? That's the question. So how much is this? Okay, let's just assume the velocity of the boat is v. This is exactly what we need to find out. Now please understand, the person is moving again 4 with respect to the boat. Now look at this. The boat moves v meters behind. How many meters behind? V meters behind. The person moves with respect to the boat 4 meters per second. Again, the boat moves v meters behind. The person moves 4 meters with respect to the boat. How much did the person actually move? Think. The boat moves v behind. The person moves 4 ahead. 4 minus v. How much is it? Hi Nitish, welcome aboard. Hi Chitra. Hello Drishti, welcome. Pandu is coming back again and again. How much is it? Think. V behind and 4 ahead. How much did I move ahead? 4 minus v. Not v minus 4, Roshni, be careful, because I have actually moved more. V behind, 4 ahead. How much did I actually move? 4 minus v. Is that now clear, my warriors? This velocity will now become 4 minus v. Okay. Now, again, going back to this external force, net external force is 0. Therefore, acceleration of center of mass is 0. Therefore, velocity of the center of mass is 0 and it remains 0. And velocity of center of mass, again, m1 v1 plus m2 v2 divided by m1 plus m2. This is 0. So, m1 is the mass of Pandu. Mass of Pandu is 25. v1 is 4 minus v. m2 is nothing but 100. And the velocity is minus v. This whole thing divided by 25 plus 100. This is 0. Okay, 25 into 4, that's 100. Minus 25v minus 100v, that is 0. And let's see what do we get over here. So 100 will be equal to 25 plus 100, 125. So 125v. So divided by 25, 4, divided by 25, 5. So v will be 4 by 5, which is nothing but 0.8 meters per second. That means it should be option C. Done, done, done. Yep. Clear? Yep. 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 It is 4 by 5. Excellent. So I hope you understood that the concept of a net external force is equal to mass into acceleration has a lot of applications, and that's what we saw. And you will see lots of questions like this, and I have put up some homework questions for you so that you can solve them. So your first homework question, okay, this is the one, put it up in the comment section. This is the second homework question, and this is your third homework question, and this is your fourth homework question. So beautiful questions for all of you, and I'll be posting the answers and the solutions in the Telegram channel. The link is there in the description box below, and you will find a lot of things out here in the description box. The most important thing, oh, by the way, we should also see who and all have done the homework last time. And when was our last class? Oh, it was quite some time back, and this was lecture number 3. And there we go, that's me last week. And thank you very much, Ishpreet, Roshni, Saja, Anil, Chitra, Suzanne, Paulmi, Madhurima, Satvika, Sweetie. Okay, some people are asking, is this also useful for NEET exam? Yes. Is this lesson the same as system of particles? No. Okay, very good, Nikhil Sai, Harita, Raghutanam, Knight, Uday. Why Sengage is not good? I think I replied to you. Sonu Nigam Light. Oh my god. Lemon Aditya Ingole calling me Sonu Nigam Light. That's a nice nickname for me. Sonu Nigam Light version. So you need to pay for the Sonu Nigam Pro version. So where is the Sonu Nigam Pro version? Sonu Nigam Pro version is over here in the description box below. Even in today's description box, you will find all the links. Just click this link and you will be able to join the Sonu Nigam Pro version. The Sonu Nigam Pro version, what you will get? You'll get topic specific short courses, revision courses, and this is a long term batch for 2 years. Apart from this, you'll also get my micro courses, and you have the option to learn in English as well as Hindi. That's what you will get. And you will also get test series, assignments. You'll also get this beautiful book. What is this beautiful book called? Come on, this is called Tattva. It has got summary, concepts, problems, level 1, level 2, level 3, level 4, previous year mains, previous year advanced, everything. Doubt solving on the mobile app that you need to go for classic. And if you need personal guidance, you need one-to-one special person, go for plus version, you will get personal mentorship. So the 2-year course price is 57,999. When you use coupon code SHHPR, you get 50% off for 1 month. So if you're trying out for 1 month, you can see this price, 1,500. That's crazy. And if you want to buy the complete course, yeah, go ahead and you can use the coupon code VENTHUSERES because there is a EdFest going on. And in this EdFest, you get 50% off on 1 month course and 10% off on the full term course. So keep this in mind and make sure you apply the correct coupon code and join now because the courses are starting on Monday. You cannot miss this. You cannot miss Shreyas Sir. You cannot miss Sonu Nigam Pro, or else you will always remain on Sonu Nigam Light. Okay, so these prices are the old prices. You will see more discount on this, and this is only limited for the next 1 or 2 days, not more than that. Yes, he was a singer and he sings lots of songs for Kannada film industry as well. Yes, Guru Murthy, I will definitely announce this very soon. Thank you, Guru Murthy. Bye bye. Take care. This was your Thalaiva. This was your Cap Toast Shreyas going live. And I'll meet you soon tomorrow at 5:30, 7:30, both the times. And till then, stay safe, solve the homework, post it up in the comment section. And don't forget to like and subscribe the video. Bye bye. Take care. This was Shreyas here. Hasta la vista.